Okay, so let's look at try number 4. Write each quotient in the form a plus bi, where you have fractions with complex numbers in the denominator. So simplify by multiplying your complex conjugates, and try to get a fraction without a complex number in the denominator. So pause the video and come back when you're ready for answers. Okay, are we ready to check answers? So let's look at part A. 80 divided by 2 minus 6i. What's your complex conjugate? 2 plus 6i. So you're going to multiply 2 plus 6i over 2 plus 6i, which will give you 160 plus 480i over 4 plus 12i minus 12i minus 36i squared. And then you simplify, you should, so that's gone, and then that's plus 36, and so 36 plus 4 would be 40. So you have 160 plus 480i divided by 40, and then if you simplify that, it should be 4 plus 12i. So 4 plus 12i should be your final solution for A. Part B, you're going to do the same thing, and if you multiply the complex conjugate and simplify, you should get negative 2 minus I. Okay, so if you got both of them correct, good job. If you didn't, please go back and try to solve it again. Let's look at example 5, factor a sum of squares. How can you use complex numbers to factor the sum of two squares? A, how can you factor the expression x squared plus y squared? So first of all, we want to figure out the factors, right? This is this is called the difference of two squares. There's a property for factoring out the sum of squares. Okay. So first of all, you want to make your second term a negative. X squared minus a negative y squared. And how can this be a perfect square? Right? Negative 1. So like usually you don't want to make positive into negative, right? So this is not going to be factored out completely in a real world. But using imaginary numbers, we can factor it out. If you have x squared minus y squared, then you'd be able to factor it out nicely. But x squared plus y squared doesn't have real factors, right? Where it factors out nicely. So this is the most simple way to write it in real numbers. But now that we know complex numbers, we'll be able to factor this out because negative y squared would be possible with imaginary numbers, right? Because I squared would be negative 1. Does that make sense? So if we have yi squared, then we have y squared and then I squared, which is going to be negative y. Magic. So using this information, you're going to factor it using I, and you can finally factor it using x plus yi and x minus yi to be able to factor using difference of two squares. Okay, so usually only x squared minus y squared would work in real numbers, but we can also factor out and make it more simple or maybe it's not simple, but we can still factor out further using complex squares for x squared plus y squared. For any numbers for x and y here. Okay. So part B, how can you factor the expression 12x squared plus 3? So first of all, see if there's any GCF. We have 3 as a GCF, so you're going to factor out 3, and you have 4x squared plus 1 left over. And then we have this form x squared plus y squared. Normally in real numbers, when you're just using real numbers, you're going to stop here. That's the most simple polynomial you have. But if you want to, if you can factor out using complex numbers, imaginary units, then you can go further. 3 times 4x squared minus I squared would be possible, right? Using differences of squares, and then you can split them into 2 factors. So that's why we want to change plus y squared, or plus your second term square, into minus negative of that term square, so that we can use the difference of squares. This is called the difference of squares. Okay, so this is the strategy we have. First step, if you see any form that looks like x squared plus y squared and you feel like you can't factor it further, you still can using imaginary numbers. So you still use the differences of squares, but using imaginary numbers if you see something like that. So let's look at try number 5. Factor each expression, part A and part B. That should be 8y squared plus 18. I don't know why that 8 is really small. But anyway, pause the video and come back when you're ready for answers. Okay, are you ready? All right, so part A, you're going to factor out 4x squared plus 25. And you know this is x squared plus y squared in the form x squared plus y squared. So you're going to rewrite that as that form. 2x squared minus negative 5i squared would be 25, right? Positive 25. Yeah, so then you can factor out using the differences of square. 2x plus 5i times 2x minus 5i. Okay. Wait, sorry. I don't need a negative here. Yeah. Okay, so part A should just be 2x plus 5i times 2x minus 5i. All right, part B. 8y squared plus 18. You're going to rewrite this as 8y squared minus 18. And then that just means you have, actually, let's factor out the GCF, which is going to be 2, right? 2 times 4y squared minus negative 9. And then you're going to use imaginary number for that. So that's 3i squared, right? And so that's going to be 2 times 2y plus 3i times 2y minus 3i. So finally, this would be 2 times 2y plus 3i and 2y minus 3i. Okay, so that was example 5, factoring sum of squares using complex numbers. Let's continue with the last example in the next video.